When I think about building reliable software systems, I often look at what the incidents that happen in the real world and see what I can learn from them. So today, let's talk about the recent train derailment in East Palestine, Ohio. So the first thing I noticed when I was reading about that is that it turns out that there are over 1,700 train derailments each year. I was shocked. They don't show up in the news, but it seems like there are on average 4 a day. It's just that most of them don't have that large scale impact. But that's actually lesson one, that the way to deal with the big issues is to deal with every issue, because you can't tell whether something is going to happen out in the woods somewhere or it's going to happen near a city. Similarly, in the software, dealing with, something might be a big outage or a small outage based on the impact it had, but reducing outages overall is really how you fix that. Then the second thing I noticed when I saw that event is that the failure happened between two measurement points on the heat of a bearing. And, the bearing failed, the train fell over. And so it turned out that they were measuring it once every 19 miles in that area. And, it failed between those 2 points. One of the key lessons when you do look at feedback control is you need to measure at least twice the rate at which something can go wrong, or at the control that you're going to apply. So, for example, if you're going to apply a brake to an engine automatically, you're going to need to measure that at least twice as often as it takes to brake and reduce the temperature, right? That makes sense, right? And that's Nyquist sampling theorem from feedback control theory for those who care. But that's really hard to do because it gets expensive, right? And that's one of the challenges, I think, in software, when you're taking a lot of data and moving it offline to some third system so that it can be monitored. Instead, I really like to measure the systems where they are and run a tight loop right there on the box. And that's what we do. That's what systems like NetData do. And I think that really gives you the highest fidelity, lowest cost, most scalable way of building these systems. But the first thing to know and understand as you're designing a reliable system is how long does it take between observations in which something might fail? And then how do I figure out how to increase my sampling rate so that I don't have to worry about it? The third thing that I kind of take away from this is that, one of the reasons people weren't measuring as frequently as they could or had a super long train here is because of the costs involved, right? And that's one of the problems in building reliable systems. Systems fail pretty infrequently. It's just that the problems can be catastrophic. So if something is failing 1 in 1,000 times, it's really easy to, sort of improve your costs because you're paying the costs all the time by not doing stuff. And so the way that we as reliability focused people can get around that is by making sure people understand the large cost during the failure, the frequency of the failure, and then helping people understand the overall cost, let's say over the course of a year, to understand whether it's economically appropriate to make to apply that, extra resources into reliability. That might, in our worlds, affect whether we have backups in another region or a second database that's acting as a standby or extra resources that we're paying for in case a data center goes down. But, because on a day-to-day basis, those seem like useless costs, but when the failure happens, that's when they become valuable. Finally, I think one of the things that software does better than the real world is that we strive really hard to build blameless cultures, ones where we focus on the facts on the ground and what are the ways to make the next thing better than the current thing, as opposed to who is at fault and, how we ascribe blame and win political points. And, I saw a lot of that in the train derailment, for example. And I'm thankful that, we've built blameless cultures in software reliability engineering. Hope you found that interesting. And I'd love to hear your thoughts in the comments.